Mr. Biggers here, and today we're going to quickly go through Unit 5, Lesson 6 with congruence on rigid motions. I'd like you to pause the video and try the warm-up before I go ahead and get started. Okay, in the warm-up, we are given that triangle BCM is congruent to triangle ZYR. We need to find each missing measure angle. Remember, yesterday we learned CPCTC, which means that corresponding parts of congruent triangles are congruent. Watch yesterday's video on Unit 5, Lesson 6, or Lesson 5 for more information on that. So we're going to mark our corresponding parts. I'm going to go ahead and quickly color code them. And then we're going to find the missing angles. Also here, we haven't learned it quite yet, but I do want to provide you with the missing angle measures. We know that angle C corresponds with angle Y, so I'm going to go ahead and write that in. I'd like you to do the same. And then we also know that triangles sum to 180 degrees. So what that's going to do is, in this triangle here, since we have the two angles, we're going to take 180 minus 103 minus 45, and that's going to give us the missing angle measure here, which is 32 degrees, okay? We know R corresponds with M, so I'm going to write that there. We also know that Z corresponds with B, so I'm going to write this here. I'm also going to copy any corresponding side lengths. RY, based off the congruency statement, corresponds with CM. YZ corresponds with CB, so that's 8 meters. And then this long side corresponds because corresponding parts of congruent triangles are congruent. We have now labeled all of our sides and all of our angles, and we can use that to fill in the problem. The length of CM is 11 meters. The length of BM is 15 meters. The length of YZ is 8 meters. The measure of angle B is 45 degrees. The measure of angle M is 32 degrees. The measure of angle Y is 103 degrees. Remember, corresponding parts of congruent triangles are congruent, okay? So we're going to read through these couple of examples here and see if we can figure these out. Jordan claims that if you know all three angles of one triangle are congruent to all three angles of another triangle, then the triangles must be congruent. So she's saying that all three angles, so you have three angles, which means angle, angle, angle. We know we do not have that as a triangle congruence. So this is a counter example. It proves it wrong. It's not able to be used to prove triangles are congruent. Down here, Liam is arguing that if you know two sides of are congruent and one angle is congruent, then triangles must be congruent. Well, he didn't say what order the two sides are. So you could have this, you could have this, which we know we don't need to be writing on our papers. You could also have this. So while side angle side works, these two do not work. We don't want cuss words on our paper, okay? So what's the counterclaim? Excuse me, the bell rang. What's the counterclaim or counter example? This one, SAA. It is not possible to prove triangles congruent. We're going to start here with problem 1 really quick. And on the you try, I want you to pause the video and try it out. So problem 1 says quadrilateral ABCD is reflected across the x-axis and then rotated 180 degrees about the origin to create quadrilateral EFGH. So what we know about a rigid motion is that quadrilaterals do not change size or shape, okay? So the valid congruency statements here that we have is that AB is congruent to EF. This is true, okay? We can also say that angle C is congruent to angle G because corresponding parts are congruent in figures as well. This is also true. CD is congruent to FH. Order matters. It works, okay? We also have that angle B is congruent to angle F. That works because they correspond. They line up in the order. And then we have, last but not least, AD is congruent to EH. So AD, EH, they correspond with each other. They're in the same order. Those are the correct congruency statements. Okay, remember, a rigid motion preserves size and shape. So really, we don't even care that it's being reflected or rotated. Quadrilateral ABCD is still congruent to quadrilateral EFGH. Okay, now if you pause the video and try the next one, once again, here's the answer. A translation preserves size and shape. So does a reflection. So I don't care about what's happening to the figure. I care that these two are congruent and they correspond with each other. All of the following are correct answers. Okay. Onto the back side here, we've got triangles ABC and A double prime, C double prime, and B double prime. So they're shown in the plane. So triangle ABC has been transformed onto the triangle A double prime, B double prime, C double prime by a rotation initially. And the rotation, if you think about it, would have the triangle right here where I'm drawing this red line. So from that red line, it also has to slide down, so it's a translation. Okay? This transformation's rigid. It does not change the size or shape of the figure. So as a result, the two triangles are congruent, okay? So we know corresponding parts of congruent triangles are congruent. So like angle B would be congruent to angle B double prime. They line up, they're congruent, okay? You try these, see if you can figure it out. Here's the answers. Quadrilateral CDEF has been transformed onto quadrilateral C double prime, or C prime, D prime, E prime, F prime. This is also by you can see it turns, so it's a rotation. And then if it turns, I look here, you can see point C is at -1, 3. Point C prime is at 4, 3. So it got flipped around here. So the way that we need to handle this is it's a translation. It got slid. Okay? So once again, a rotation followed by a translation. It's a rigid motion. It doesn't change the size and shape. Now a dilation does, so that's going to change. So as a result, because it's a rigid motion, these figures are congruent. That is your 5-6 notes. Make sure you have those and study this material to help you for your Unit 5.